Hello and welcome back. Equations for today. Not a standard equation, not the kind of thing you're likely to see in a normal exam, is possibly enrichment. What we are trying to do in there is not actually to solve it. He actually says, the question says, this is the equation, and it says, show that x is equal to 2 is the only real solution. So that is the only one that will balance this equation. So we have to think of basically how we're gonna actually perhaps solve it and actually show as a result there's no more solutions to this particular equation. X cubed minus 6 is equal to the cube root of x plus 6. Do we cube both sides of this equation? That's the first question I'm asking myself. I wouldn't like, probably I would have tried it, but I don't know if you can see, if you cube this one, of course you're going to get an x plus 6, but this you're going to get obviously powers of x to the 9, x to the 6, x cubed, then you're going to have of course some constant and some constant there, so let's write it as x to the 0, and on the other side of course we're going to have x and more constants. I don't think I'll be going places having a polynomial that has 9, 6, 3. We also have a 1 and then a constant. Trying to factorize it, I will know of course one of the solutions is of course the bracket, or I don't know what solution, one of the brackets in the factorization will going to be x minus 2, but I don't think I will be fancying my chances reducing that to an x to the 8 and going from there. So this is not sensible. So what else can I do in there? All right, possibly a little substitution is in order, and say perhaps let's call this particular cube root equal to the cube root of x plus 6. So that will make things a little bit easier. The same way you do a substitution when you're having integration. This is very, very disgusting. Let's replace it and let's see if we can get some kind of relationship between u and x as we've written it in there. So if we cube this particular substitution, we're actually saying, okay, u cubed is equal to x plus 6. What can we do now from there? Not a lot. Okay, we haven't done anything exciting so far. Maybe we can write it, I guess, as x on this side is u cubed minus 6. But then when I've written it like that, I'm observing something which is kind of like, I see some kind of symmetry perhaps. If you look at the original equation and you look at the u cubed minus 6, x cubed minus 6, and the x on this side, wait a second, I'm thinking to myself, let's pause for a second, let's put the brakes here, and let's look at the equation again and say, all right, if that is the case, when I write the equation x cubed minus 6 is equal to u now, because of course I call this u, and I rearrange this particular equation for u this time, and I look at it a little bit closely. So I'm comparing essentially, let me just use some red pen to actually see what I'm looking at. I'm comparing this line here and this line here. X is u cubed minus 6 and u is also x cubed minus 6, the other way around. What can I conclude from something like that? Well, quite clearly, if I replace in either equation x for u, it leaves the equation invariant. So it doesn't really matter on which one. If I call this x and this u and swap them, I'll get that and vice versa. So the conclusion is in fact the u and the x must be the same. It makes no difference, and therefore I have a very good relationship between u and x. What can I do with this relationship? I can finish my problem now. I don't like u's, I'll go to x because obviously my equation is in x. So I'll take either of those two equations, all right? Place where I see u, x. So let's say on this one, x instead of u is equal to x cubed minus 6. And this will now give us a cubic. X cubed minus x to the right minus 6 is equal to 0. That's much easier to factorize so long as we have nice factors, and in fact it's telling us that x is equal to 2 to show that it's the only real solution. So I know definitely a factor, and even if it didn't give me that, I suppose I could easily here just try a few numbers that divide 6, like plus or minus 1, plus or minus 2, plus or minus 3, and so on, and come up with a factor. We can just verify very quickly, just in case we made a mistake. 2 cubed minus 2 minus 6, 8 take away 8 is indeed 0. So yes, the x minus 2 is a factor. You can do a little long division here, or you can manipulate it. I'm going to manipulate it because I can't be asked to be writing a long division, but use your favorite method. So what I'm going to say there is this is x squared, x minus 2. That's the bracket I know is in there. So I'm going to rewrite this cubic in a very strange way. I don't know if you've seen this before. X cubed minus 2x squared just been created. So now I need a plus 2x squared to balance it. So there's my plus 2x bracket x minus 2. Minus 2x squared plus 2x squared cancels, so I have no x squared in there. And I've created in there now a minus 4x. But I only need a minus x, so I need to add 3x. So plus 3 bracket x minus 2. There's my plus 3x. There's my minus 6 that appears. And of course, that is perfectly balanced. All I need to do in there now is to pull out the x minus 2 at the front of this, as a common factor at the front of the right-hand side. And that will leave me in there an x squared there, plus a 2x, plus a 3, and it's telling me x is equal to 2 is the only real solution, which I can see in here. So it suffices to check the discriminant there very quickly. B squared minus 4ac, and that is of course 2 squared for this quadratic minus 4 times 1 times 3, which indeed is negative. Therefore x is equal to 2, only real solution. Quite a clever problem. It's been based on functions for those who really trying to look deeply into how this question has been made. I'd actually just a little bit of an aside for people that are just genuinely interested. I've taken basically the function f of x is equal to x cubed minus 6. I found its inverse. Okay, and of course its inverse is the function that you're seeing up there, and I'm getting you to solve the equation f of x is equal to, or no, f dash, I beg your pardon, f to the minus 1, and I'm getting you to solve the equation function is equal to its inverse, which they will meet of course along the line x is equal to 2, which I had ensured it actually has a solution there. And then of course this happens is an inevitability of functions. Okay, I hope you enjoyed that. I hope you learned from it. Who's laughing now?